Section 4.5, dilations. So a dilation is a transformation. It is the only non-rigid transformation we're doing. That is, the first shape and the second shape are not going to be exactly the same. A dilation is something that makes your shape larger or smaller, an enlargement or a reduction. So let's say we have, I don't know, a triangle here, and then there's a triangle here. This could be a dilation. It would be an enlargement perhaps because the shape is getting bigger. Now the center of dilation is a point C. Think of it kind of as like a spotlight and a projector. So there's the light that takes a picture and makes it bigger. The light would be the center of dilation. If you're thinking maybe shadow puppets, it's a flashlight taking the shape of your hand and then making it bigger. We use dilations a lot, making pictures bigger and smaller. My guess is that probably at some point in time today or this week you have taken a picture and then zoomed in or zoomed out. Those are dilations. You're taking something and you're making it bigger or smaller. They use it a lot in projects like movie making and things like that to make things bigger or smaller, drawing something to scale and then making it bigger. We use this quite a lot. The scale factor K is how much bigger or smaller we're making it. You want to make it bigger or smaller following a ratio. That is, picture if I took a picture of you and then I made it 1 inch taller but 6 inches wider. What would happen to your picture? You would look a lot wider. It would look like you had really broad shoulders and a wide body. When you make the picture taller, you want to make it wider so that it doesn't distort how you actually look. So we do that by following the scale factor K. K is the image over the pre-image. And this is a tricky one. This is one that I myself even flip, because think in your chart, A goes on the left, A prime goes on the right. Which one is the image? Which one's the pre-image? Pre means before or first. The pre-image is A. The image is A prime. So it's the A prime number over the A number. And we want to do the distance to the center of dilation. So here, if this was 3, this distance, and this distance here was, I don't know, 12, this was A, this was A prime, you would do 12 over 3. Which is 4. Now, an enlargement versus a reduction. How do you know if the picture is going to get bigger or smaller? K is bigger than 1. So in K equals 4, as I said up here, this was an enlargement. A reduction is going to occur when your K is between 0 and 1. Now, if K is negative, it's actually flipping your picture in the opposite direction also, but most of the time we deal with a positive K value. So if K is between 0 and 1, maybe K was 0.2, or K could be 1/2. It could be a fraction or a decimal. As long as it's between 0 and 1, then that is a reduction. Now the nice thing is that these are also fairly easy to do, especially if you have a calculator, because what you do is in your little chart, you have your xy's over here. Over here, you do K times X, and you do k times y. I talked about you want to follow one ratio. You don't want to change the x faster than the y, the height faster than the width, or the other way around. You want to change them at the same ratio. So what you do is you multiply all of your x and all of your y by that scale factor k. So let's look at example 1. Find the scale factor of the dilation, then tell whether it is a reduction or an enlargement. So remember, scale factor k is the image over the pre-image. That is A prime over A. Now in this case we don't have any A's, but we do have a P prime and a P. So the distance from C to P prime goes on top, and from C to P goes on bottom. We're told this distance is 4. That's the bottom number from the top to the bottom shape. But we also need this distance right here. So please be aware, the 2 is actually on the wrong part of the picture. We need this top distance. But we can use segment addition postulate to say the whole piece is 4, the bottom is 2. So the top also has to be 2. So they add up to the total of 4. Reduce it, your scale factor must be reduced. The scale factor is 1/2. Now is that an enlargement or a reduction? You have 2 ways to go about this. 1/2 is a reduction because it is less than 1. But also look, if this is your first shape, P, and this is your second shape, did it get bigger or smaller? It got smaller, it was a reduction. Let's look at B. K, it's A prime over A. P prime, the distance from C to P prime, this one up here, is 25. C to P is 20. 25 over 20 reduces to 5/4. If you're trying to reduce on your calculator, if you have the TI-30X2S, if you use the fraction key, the ABC key, and you type 25, ABC 20 equal, it will give you an answer of 1 and 5/4. Then click second ABC equals, and it will switch it to 5/4 for you. Your calculator will reduce this stuff if you know how to use it. Enlargement or reduction. P. This was our first shape. This was our second. That's an enlargement. It got bigger. And our K is bigger than 1. I personally usually answer reduction or enlargement first, and then I find my K and I check at the end to make sure that they match. That if I thought it was an enlargement, my answer should be bigger than 1. Let's do C here. K, A prime over A. The distance from C to P prime is 27. From C to P is 9. Scale factor is 3. That is an enlargement. For 2 reasons. First reason is this is bigger than 1. Second reason is this was our first rectangle, or first shape. The second shape was bigger. It's an enlargement. Let's actually do them now. So graph the polygon and its image after a dilation with scale factor K. And we have ABC and a K equals 2. So let's start by graphing. -3, 1 is A. -4, -1 is B. -2, -1 is C. Now when we do these, we're going to start just the same as before. Going to write your points down just like we did before. Make your T-chart just like we did before. A, B, C turn into A prime, B prime, C prime, just like we did before. K equals 2. What that means is that you're going to take the x and multiply it by 2. Do 2 times x and 2 times y. Now, although I did want you in section 4.1 to actually show me the x minus 3 and the y minus 2 or whatever the translation was in 4.1, I wanted you to write it down. In section 4.5, I'm okay with you multiplying. Tell me what you're going to multiply and then just do it. What's -3 times 2? -6. What is 1 times 2? 2. -4 times 2? -8. -1 times 2? -2. -2 times 2? -4. -1 times 2? -2. Graph them. -6, 2 is A prime. -8, -2 is B prime. -4, -2 is C prime. The triangle or the shape will be bigger. It's going to be a bigger or smaller, perhaps, picture thing that you plotted, but it still should generally be the same shape. So this triangle, which was fairly even, is still fairly even. If you make it bigger and it's suddenly lopsided and it wasn't lopsided to start with, then probably something went wrong. Here, the picture doubled in size because K was 2. Example 3, last one. Graph the polygon and its image after a dilation with scale factor of K equals 1/5. So same idea. Let's plot them first. P is -10, 0. -5, 0 is Q. 0, 5 is R. -5, 5 is S. Still make your chart, just like before. PQRS will turn into P prime, Q prime, R prime, S prime. A K of 1/5 means we're going to do 1/5 times X and 1/5 times Y. Now you can kind of go about the arithmetic any way you want. I do want to point out though that 1/5 times 10. To multiply a fraction times a number, make it 10 over 1. Multiply straight across the top. 1 times 10 is 10. Multiply straight across the bottom. 5 times 1 is 5. 10 divided by 5 is 2. So -10 times 1/5 is -2. 0 times 1/5 is 0. Another way to multiply or to deal with this is that multiplying by 1/5, 1/5 times x is the same thing as x divided by 5. So instead of multiplying by 1/5, I personally actually just divide by 5. Negative 5 divided by 5 is negative 1. 0 divided by 5 is 0. 0 divided by 5 is 0. 5 divided by 5 is 1. And then we get a negative 1 and a 1. You can do fractions and multiply. You can change it to division. It's up to you. The arithmetic aspect of it is whichever way works best, or use a calculator and do it that way. P prime is negative 2, 0. Q prime is negative 1, 0. R prime is 0, 1. And S prime is negative 1, 1. And our image is smaller than the pre-image by a scale factor of 1/5. Example 4 we will not do because it requires your compass. With this said, you should have enough information to do your homework for section 4.5.